You've probably heard of prime numbers. A prime number is a whole number that doesn't have any factors except for one and itself. So for example, 13 is a prime number, because if you test it with the divisibility rules, you'll find that it doesn't divide evenly by 2 or 3 or 4 or 5 or 6 or anything else. The only two factors are 1 and 13. There are other prime numbers such as 2, 3, 5, 7, 11, 15, 17, 19, 23, 29, 31, 37, and so on. In prime factoring, you're going to make something called a factor tree to find out all the prime numbers that are factors of a number. So for example, what are the prime factors of 30? Okay, so using the rules of divisibility, we can see that the number ends in 0, so we'll divide by 2, giving 2 and 15 as factors. We just found out on the previous screen that 2 is a prime number, so that's as far as we can go with that one. But using the rules of divisibility with 15, we can see it ends in 5, so it's divisible by 5, giving 3 times 5 as factors. And these are all prime numbers, 2, 3, and 5, so that's as far as we can go. And the prime factors of 30 are 2, 3, and 5. And these are the prime factors, not all the factors. All the factors would include 1 and 30 and 15 and 2 and 3 and 5, and any combination of these prime factors. So 2 times 3 is 6, that would also be a factor, and 2 times 5 is 10, that would also be a factor, but we were looking for prime factors. But what if I did it differently? So we start with 30, and we look at it and we say, oh, well, it's 30. 3 times 10 is 30, so 3 and 10 are factors. Well, that's right. And 3 is a prime number, so we can't go any further than that, so we'll bring that 3 down. But 10, we can factor 10, and we know that 2 times 5 is 10. Well, look, we ended up with the same prime factors. 3 and 2 and 5 are still the prime factors of 30. So it doesn't really matter how you go about it, you'll always end up with the same prime factors. And again, if we wanted all the factors, well, this doesn't give us that, but we know that 1 and 30 and 10 and 3 and 2 and 5 are factors, and any combination of these prime factors, so 3 times 2 is 6, and 3 times 5 is 15, those are all factors of 30. So let's do one more example. We'll find all the prime factors of 48. Okay, so with 48, it's an even number, so using our divisibility rules, we know that that's divisible by 2, and you could divide it out with long division, but I know that the answer is 24. 2 times 24 is 48, and 2 is a prime number, so we can't do anything more with that. But 24, we can factor that more, so 24 is 2 times 12, because it's also an even number, so using the rules of divisibility, I know. I could have tried 3 or something like that as well, but I'm just sticking with 2 for now. Alright, so again, 2 is a prime number, so we're just going to bring that down. But 12, we can factor that more. Let me see, I could divide it by 2, but I also happen to know that 3 times 4 is 12, so I'm going to do that one instead. But as we know, it's going to give us the same answer. So 2, these are all prime numbers. 3 is a prime number, but 4 is not. I can factor that more. So these are the prime factors of 48. 2 times 2 times 3 times 2 times 2. And you'll find that factoring becomes very important as we move on to other areas of math.